So hello, everyone. Nice to see you all again. Uh, as always, add stuff to the notes if you like. Get started on a few agenda items here. So after we get through the quick reports on things, I'd like to do a PR status update. So we can go through and look at all the PRs, and if they need assignments, we'll review our assignments. We can have people volunteer to do that and get things going. Also, some announcement, Thibaut is going to be doing a seminar soon for August. Thibaut, do you remember, what was the date that we decided on for that?
I think it's just send a email with a calendar invitation, and it's for Thursday 12 at 10.
Okay. Thursday the 12th at 10.
Yeah. On that note, actually, so I don't think she sends a newsletter yet, and that's going to be part of the newsletter, but she also asked Joe and I that if you guys have updates that you would like to share and contribute to the newsletter, just send a message on Slack or to Lindsay directly, so it's added to the newsletter.
So Devin, were you going to kind of take charge of the newsletter? Kind of forgot where that was.
I don't recall agreeing to do this, but I could.
Oh, well, I don't know, I might be mistaken. Just that somehow I'd kind of thought we discussed, some time ago about you maybe taking over, and then you were concerned about it being a little bit time consuming, and then Lindsay was trying to convince you that basically it's just providing a format and people providing the stuff, but somebody to coordinate and send it out on a regular basis. Anyway, we can talk about that later, but somehow having one person that is kind of in charge of this so that it kind of happens on a regular basis would be good.
Mm-hmm.
Okay. I believe so. Lindsay had I dropped the link to the newsletter in there that Lindsay put up on Slack. I dropped it in the notes for you guys. We'll move on to some quick reports here. So I've basically finished going through the discretized talks. I finished that this morning. Just was writing a PR before the meeting gets started to push up there. So I'll have noted things in there, just kind of like conventions that you should try to stick to. Just some notes, but it was like kind of my running track of things that I've seen, like just, okay, well, let's make a consistent style for that we're using. So it'll be nice. They're looking very nice altogether. Like definitely, there's a lot of stuff in there that looks very. I'm very happy with the discretized, the way the discretized docs are going to look.
Oh, that's good. Yeah.
It's
one thing that's also gonna speed up working with SimPEG is getting that similar, I guess, extensions and formatting and all that stuff, so that that website will build.
Mm-hmm.
And then I can just get rolling on that.
It's like the docs have started to take a while to build themselves, but it looks so much nicer than it did, in my opinion. Like it's much easier to follow, and like all the information is there that you'd want.
Yeah, it's so much easier to figure out what's going on.
Yeah. So we'll get that in, and then then we should revisit the tutorials.
Yeah, we'll see how much needs to really be revisited, because the descriptions of a lot of functionalities really, it's a lot better now.
Mm-hmm.
But I still would like to keep them in some capacity, just with the language of, oh God, I have no idea what I'm doing, and how does this fit into the grand scheme of things? Like that's sort of what those tutorials need to be. we've now kind of figured out, well, yeah, in the doc strings, we now have explained what the syntax is for constructing the stuff and applying it, and that doesn't really need to be in there anymore.
Right. I think it'll probably just take a quick pass through. We can, add some links where appropriate, and remove things where appropriate, add things where it's appropriate. I think it'll probably just take a quick pass through and it'll be great.
Yeah, okay. I guess I was thinking well, you want to wait until the API stuff is done before you don't really want to add that to the PR, do you?
No.
No, okay. So, I mean, you can look, I don't even know if I'd bother looking at it yet, because it's going to be a few weeks away.
Yeah, I'm just saying, like, we need to revisit that now that the API documentation is finished.
Yeah, for sure.
Okay. Other than that, I know I still need to upload some more YouTube videos. I'm sorry, I've gotten behind again. I always forget about them.
Could it be done automatically or not? I'm not even sure.
No, I've tried to look up ways to automatically upload them from Zoom to YouTube. I haven't found anything. Like, it would be really nice if they just like went up there and no one had to worry about that. But I will look into it some more. Maybe it's changed. John, got you up there next.
Yeah, nothing too much. Yeah, I didn't get to the pull request stuff this week. I finally got my cluster up and running, so I've been playing with that. Yeah, having some good success there. Joe, yeah, you were definitely right about, it's just that simulation object. Even if you're just storing the operators, it just seems that when you get to the big enough problem, it still is it's a big graph. Like you're passing around a lot of data. So what I've done is I've pretty much made like a faux, or I guess like a sub simulation, like the tiled simulation. I've just made a light version of it. That's just pretty much like a JSON file that sends, and then each worker loads up its tile. So I've kind of changed the tiling so that it's now its own worker, and it's just concerned with its own data, and it loads it up on that other server or that other node computer. Each node is just a tile. And you just send it, or what I'm working on right now is you just send it that change in the model vector, so that if you ever need to calculate the fields or you want to calculate J kind of thing, you just send it to those workers and they spin it up. And Kubernetes is actually really nice for that. I was trying to do a simple version with SSH, just SSH into them and running individually, but I swear that I hooked up set up everything that it's identical, but there's still like, it's not finding certain stuff in SimPEG. It's saying that like the DASGet fields isn't there, but when you look at the thing, it's clearly there. So Kubernetes is just a lot nicer, because then you can just spin up an image and there you go. Everything works. But yeah, hopefully I was maybe going to do maybe October. I should have quite a bit of stuff to show. Maybe I'll sign up for that one and expand on this using distributed computing for the inversion.
Cool. I'm glad it was like helpful. Is it speeding it up like a lot to do it that way?
Yeah, it's not only speeding it up. Well, I guess it's still using a lot of RAM, but yeah, so far I've got like a 2x speed up, but I've only got 3 nodes right now hooked up.
So what did change, John? Because I thought we already done it, that the worker was only caring about its own simulation. What had to change? I guess I can look at the code. We don't need to go to the details.
Yeah, it's still like when you want to send it to those workers, it still has to send that whole simulation object, even though that it's concerned with that. Well, I guess I have a little bit of a different problem, where when we were doing it, we were able to do the like sub-meshing. We didn't send a global mesh to it all the time. And with Diaz, I have to send the global mesh. So you're not really, it's a big size. You got to send this huge mesh and simulation to every worker. Whereas what we were doing with the Octree, you can lighten the load a bit to everything.
Yeah, but again, why are we sending the mesh where we could just store only the operators? That's what I was saying, right?
Oh, sorry. Yeah. I guess in that case, even with the storing the operators, like I tried the full, that full data set that we had from yeah, that one that we worked on. I don't know if I can pass on the name or not. Yeah, I tried that whole one again on the new simulator, on the new tiled simulations, and the graph is just huge. It's like 40, 50 gigabytes, even that we're only storing the operations. Somehow that's getting sent, or it's still being generated. Maybe it's on that worker over there, but something coming back. Yeah, that's kind of where I'm at right now, is just kind of mapping where everything is coming from and where everything's going. But yeah, so far I've found is, yeah, we're depending on sending a lot to those workers still, even. Another funny thing though is it seems that the frequency domain stuff is working better. It doesn't actually make as big of a graph, which kind of confuses me. But again, I'm looking into it and seeing what it's doing.
John, compared to what?
Oh, sorry.
Compared to what? Like you said, frequency domain works
Oh,
better.
compared to the DC.
Oh, I see.
Yeah. The problem I'm dealing with right now is the DC. I find that the frequency domain stuff is working really good, even on a single machine local cluster. It runs comparable to what's out there for sure, especially 3D. But yeah, the DC code, for some reason, it just doesn't want to parallelize. Not on a local machine, anyways. There's too much thread. Even if you try to put everything to a single thread, there's still some crosstalk going on or something, or it's blocking. So then I threw it onto the individual nodes, and things are looking better now.
Maybe, I'm not sure. The only difference that I can see, the DC code, it passes, when you're passing the right-hand side,
Yeah.
it passes all the vectors. So it actually generates a large matrix and then apply the AInf. Whereas the frequency domain
Yeah.
over. So potentially, I think that's for a small problem that actually makes it speed up. But yeah, but when you're dealing with a really large problem, that I think that right-hand side at the end, like it actually changed it to a dense matrix and then then applied. So potentially that could be a place that or that could be a problem. I don't know. But
no, that's a good point, Soggy. I overlooked that. Yeah, exactly. The right-hand side is huge compared on the DC. Well, for the big problem. Yeah.
Right. Then like you can simply loop over. But anyway, it is generated and stored in each source class. So yeah, I'm not sure what's the best, but that's the same case. Even frequency domain, it is stored in a source class. So if that causes a problem, you probably just generate on the fly. But yeah, it's just a point.
Oh no, that's cool. Yeah, I'm gonna take a look at that. I bet you that is where the big plug is for sure. Nice, thanks, Soggy, for that insight.
Okay. Glad it's looking good. Kevin, you mind going next?
Yeah, sure. So I guess there's a couple of things. One was these validations I was doing for the time domain codes. And I mean, Lindsay took a look at some of the scripts that I had, and then she just did a simple step off. And that result seemed to be stable, but I'm not doing anything unreasonable with time stepping, and it should be stable because it's just using backward Euler. So there's something in there that's kind of suspect, and we haven't really investigated it yet. But that kind of opened up to me just looking at pieces of our time domain EM code and our EM code, and kind of looking for ways to improve it and looking for ways to kind of fill in all the different kind of sources and receiver types you could use with all of the different choices in discretization. So I'm kind of going through right now and documenting the theory, because we're going to need that for SimPEG when we get to the API for that. But yeah, I've kind of been going in and doing that. So I'm sort of in the process of testing stuff, trying to get the theory, seeing if there's a better way to do anything, see if anything's missing that would be really useful, that kind of stuff.
Devin, if you said it seems to work fine for a step off, but has problem elsewhere. If you just started it with like basically with a step on and just kept that constant and then turned it off, does that make any difference?
Yeah, that's the one that breaks, that was effectively what I was doing before. So I had a long pulse.
Okay.
And the part that's strange is it's not just like the whole thing goes haywire. It's at the early time channels and mid time channels, everything was fine. And then when it got to below a certain order of magnitude, it was unstable. So that kind of leads back to maybe what Joe was saying about checking the accuracy of the solve, because if you have a unit step off, the magnitude of the response, I think, is going to be it's going to be higher than for a square pulse, and it's going to be larger the longer your pulse is. Also think that maybe at later times it kind of bends down a little bit for a square pulse, but I'd have to check that.
So it's like the size of it is more related to like the slope of the ramp-ons and ramp-offs.
No,
like the DDDC and stuff. It's
I have to go and take a look and see what the numbers that came out of her simulation were.
okay.
Yeah,
So you
I'll
just
have to
have
take a
like
look.
0. You just said 0 and then 1 and 0. I guess.
Yeah,
Just square root.
0, and I started out with let's see, you can imagine the time stepping scheme I chose. If you had just a step off, you'd start with really small time steps, and then you would go to larger time steps at the last time channels. And so I did a mirror image of that, and the on time is the same length as the off time. So I have when you have the step on, you're using kind of some more coarse time stepping, because that's not impacting your response as much as right before the step off. So it's kind of like coarser time steps, you get the step on, and then it gets finer and finer and finer, step off, you're still using fine and then getting coarser. Does that kind of make sense to everyone?
Yeah, but it seems like the opposite way that you should be doing that.
So you think that
So when you have the step on, you need to have finer discretization there, and you can let it go longer and longer before it gets to right to the step off, and you need to have finer discretization again.
I think
so instead of doing like this, you would say just do a mirror, or sorry, like an equivalent one. I don't know about
I think it's if you are measuring like at the off time, and then if the pulse is large enough, let's say like, I don't know, like if you're measuring 10 millisecond, if pulse width is like 10 millisecond, I think you probably don't need to actually discretize the ramp on much. So you can do pretty coarse.
that's what I thought, because that part's not impacting my response as much as I get near and near to the off time.
The only case is like when you got very short pulse. So actually likely that ramp on makes a large impact into your off time. That's probably where you need to do what Joe suggested. But it seems like you're trying to emulate the step off with the large duration of the pulse. Then if that's the case, it's unnecessary. In general, I think that's what I have tested when I was just testing like how to generate like just using the long period of step to approximate the step off.
Yeah, because I need to do that based on my comparison for how TD Octree version 1 works.
But I'm a little bit confused. Like if step off works, why, like, do you have a problem with just putting a certain period and then see that's matching with the step off? Is that something that you're having a problem?
Well, I should be able to simulate a square pulse.
Right. But then that's not the case. It's not matching.
Yeah, and assuming that, like, well, I mean, backward Euler is stable. I wasn't expecting that at those late time channels I would have some craziness. Right? It's a stable time stepping method, and it was accurate over the range of the early and mid time channels. And then as you go to the late time channels, there's still a prominent signal. However, it wasn't stable.
Maybe you check like like a divergence of B is actually 0. I think that's sometimes a problem, like and that error is actually stacking up as time goes up. Because if you have a small error there, then after a single time step, it stacks, and then that kind of accumulates. So I think we made sure in that just the conductivity case, we make sure that, but I'm not sure when you're actually applying like a large magnetic permeability. I'm not sure that's actually well tested. I don't know. I think if that seems the case that you're trying, so a potential place where we're giving a large error could be the place. And I think that the UBC code does extra things, I guess, to correct for that, to make sure that the divergence of B is equal to 0. I think. I'm not sure exactly. I think I remember HDTD do like that kind of things, extra sort of.
It's true. There is a little matrix that gets added, I guess, to do that, and yeah. All it says is it has something to do with hanging nodes, but there was some additional consideration in the UBC codes.
Yes,
version 1 doesn't seem to work the best for high magnetic permeability, but the version 2 code, which uses an electric field formulation, works super well. So I mean, in the end, these are kind of all the things I'm diving into. So what is the best discretization for solving certain types of problems? It's kind of what we want to know so that we can lead people down the right path when they start using this package.
Good luck on that.
Yeah.
Yeah, I still think you should, like, if you're doing that step on, it needs to be discretized finer at where it steps on, because that's where the field is changing fastest, right? So in order to get a good initial, because it changes very quickly at the beginning of the time, at the beginning of the step on, right? The field changes very quickly. So if you do that very coarsely, you're not going to get an accurate start point for the step off.
Yeah, but then I mean, if I discretize it coarsely or more coarsely at that time, then it's basically like saying, oh, I'm just kind of doing more of a ramp as opposed to a true step on. And if you're far enough back, it impacts the data much less than as you get closer to the step off. So I'm not sure in the context of like the 3D time domain EM, but in terms of doing a lot of this with 1D codes and things, this has worked pretty well.
Yeah,
I'll give it a shot and see if it changes anything.
It might change it. My inclination is the other way. Like when the field isn't changing, right, you don't need to discretize it finally.
Try that. I still think you don't have to, because this PDF, that's the feature of the PDF. Like even if you got actually wrong initial, like a time stepping, like you do a very poor job on initial time stepping, but actually accuracy gets converging as you go later time. So I don't know, try, I think I'm not 100% sure. That's my intuition. So you can check.
You mentioned something interesting though about the B field not necessarily having some kind of small error because it might not be completely divergence free, and then as the signal to that error ratio gets worse, you see it.
Yeah, so we do sort of that by using the vector potential when they're generating the source term. But
Yeah, I know that part.
But then it's not necessarily still like in when you're calculating the B field by solving the PDE, we don't really make sure that. So yeah, I don't know what could happen with the large permeability.
Fun.
So let's move on to Dom with this quick report here, so we can get onto the PR statuses afterwards.
Yeah, so I've been exploring ways to be able to go from surfaces like a DXF to a block model. It's an operation that we have to do fairly often, right? And I was relying on GoCat before, and I was trying to look for an open source way to be able to do this. So we had VTK, if you guys remember, right? TKC, we're using VTK for this, but there were some weird behaviors if the surface were not closed. And so I found this tree mesh package that does ray tracing, and it's actually quite fast. So I recommend you guys to look at it if you have to do that operation. And then otherwise, I've been diving back into the Dask potential fields modules because we need to deliver things, and it was not giving the same result as before. So some efficiency there. So John, I don't know if you're touching our tiled simulation branch, but I've been working on our fork, and I would have some pretty good updates to push back.
Yeah, I think I made maybe like a minor update. So yeah, it should be all good. I've been mostly just kind of chewing away at the MTPR because once that's done, then I just have to concentrate on the DAS stuff.
Perfect.
Yeah. So
Sounds
it's all good.
I will do then a pull on my branch to see what you did, and then yeah, send it back.
Cool.
It should fix some good stuff for GravMag.
Cool.
So, Dom, you were saying you were talking about a deliverable. What was the context of that?
Well, we promised that we would give access, an analyst hookup to the latest SimPEG, basically update from the old version to 0.14 and plus by the end of, I think by October, we said. So I just need to make sure that SimPEG 0.14 runs fast and gives the output that we used to have, right? So yeah, that's deliverable. That's it from me.
Okay. If there's any other quick reports, go ahead. If not, we'll do a quick PR status and try to assign some reviews to people. So I'm just going to go through them on the SimPEG repo right now. I'm just going to do a quick status on them and see where they're at, who's reviewing them.
Hey, unfortunately, I need to switch off, Joe, but ping me, man, if you want me to be an editor on any of these guys.
Okay.
Just flag it.
I think the only one I wanted to ask you about really quickly was the Xiaolong had the cell grade or the
Cross
depth
gradient
weighting function.
Yeah.
The depth weighting function.
Oh yeah, yeah.
Just look at it again. Take a look at it again. I'm not sure if he added sufficient testing for it, but also because you and I had talked about the issue with normalizing by volume. So how you want to proceed with that, right? Because we talked about how the sensitivity weighting, like you have to not multiply by volume in the regularization, whereas the other ones you do.
Do
Right?
you want to do this on this PR, or we? I would suggest probably split it, right?
Yeah, we should definitely split it, but I just want to make sure that we still address that somehow. Like, did we end up making an issue with that? I don't remember.
I don't remember either, but I would say let's just make a decision for this one in line with what we want to do. Basically, always normalize by volumes, and then we can readjust the other regs after in a separate PR.
That sounds good.
Yeah.
Okay, that was it. Thanks.
Okay. Have a good week, guys.
Okay, so I'm just gonna start at the most recent one and go from there. So the number 1027, replace NP matrix by regular ND arrays. I'm not sure where. So is it just failing on the code coverage right now? It looks like it's just failing on code coverage for the diff. This was, I know I put in some reviews here, and Thibaut, I thought you had left some comments on it as well, because it like, Dieter, the changes like you had made originally never through errors, but I feel like they should have.
It's very minor.
Yeah,
Yeah.
I think, Mike, your comment, yeah, it seems like this code is not, like the part of the code that I wrote that was modified is like not tested. Yeah, like, so that was like the analytic for the MT1D that I transferred from one of my very first projects in SimPEG to compare and with the work that Sogi and Lindsay did with the leading edge, but I'm not sure it's been used since then, and we didn't write any tests, so it's probably something that we should have on a to-do list at the moment.
Okay. Yeah, from what I've seen, it looks like it was done, like the changeover was done correctly from matrix to array there. I didn't see anything else, so.
I mean, eventually you move that to Chihuahua, probably.
Yeah. So I think it's probably, that one is probably fine to pull in now.
And the second part with the viscous remnant, I think this one is tested, so that should work.
Yeah. Okay, so that one will be good. Gravity examples, that the next one, 1024. I think pretty sure that was just added example or added text into there saying that it, a little bit of detail in Zitora about the right-hand coordinate system.
Yeah, I'm finding people are coming into the gravity example every few months and then saying, this isn't the convention that I like to use, and then they change it. And then somebody gets mad and they change it back. Then they get mad and they change it back.
It's fortunately, it hasn't changed back. It's been consistent like with the SimPEG coordinate system, but we do keep getting people that think it's wrong. So it'll be, I'm glad that he added it in there. That should be fine.
Yeah.
The standard deviation one. I think that's all, that one looks all good right now, right? I don't, that's just it was a really simple change. I'm happy with it. Okay, PGI improvements.
That's a draft. I'm not sure if we want actually to do that, but I know that, yeah, that you can write things as draft in GitHub. So that's what
Okay.
I
We won't worry
that,
about that.
but
Yeah,
yeah, don't worry about it.
Whenever you're ready, we'll put reviewers on it.
Yeah.
See, Lindsay has an update receivers. Not sure what was failing on that one. I think it just needs to be updated to master.
It
And
is
that was-
only
That's a,
documentation.
yeah, that one's fine. Okay, total vector map. Dom marked that as in progress. So
Yeah, we're still not very happy with what we're getting. There is some like yeah, some weird things happening. Like it's a difficult problem.
okay, the
It's
next one.
I think he's implementing what he saw in that from that Iranian author where like it's MVI, but it's Cartesian MVI, but you regularize on the amplitude.
Right. Okay. Let's see. There's a remove dead code. I'm assuming it's pretty small.
Yeah, that's something we stumbled upon when Sogi and I worked together on the integration. I think it's 2 lines that were not used and then a few other things.
Okay.
Speaking of that, Joe, like is that line integral code is kind of works like both tensor and octree? Are you kind of confident now?
The line integral code for
Like
courses?
the generating like where we used that to generate the current density. Like do you remember Mike was asking us to provide like, oh, how do we generate that wire loop, like a wireline source?
Yeah, we can generate wireline sources on tree meshes now.
Yeah. So
Yeah.
do you like do you kind of now confident that like because there were a bit of issues when you first implemented that into an octree code like that?
The only issue I see right now is that it still doesn't, like, I don't think it handles if a line crosses like cells that change level.
I see.
I think that's the only issue that I saw. I wasn't, and I'm not quite sure how to get around that. So right now it just throws an error if it crosses levels. And it's like, okay, all line, like the cells should be all at the same level.
Yeah. But then
Okay.
it's also an inherent problem that we have with voxel-based code, right? Because it's an average of our cells anyway. So it's if you're too close, it's not precise. Probably in difference to finite elements where you can neatly form your cells along the source. In our case, that's just not possible. So there is some averaging error all the time, and we just have to be a decent distance away, I think.
Okay. So it's moving on. Fix for issue 771. I think, is this something still to do with? So this is definitely an old wrapper or old thing, but I think it has something to do with the initial like BFGS guess, and that it uses that solver. A few people put in a few fixes for it, but it had something. It was more to do with what I saw is more to do with like people not necessarily understanding what it was doing. We're gonna have to, I think we'll probably have to take a look into this closer, but my initial thought on this one is that having a iterative solver there isn't going to help.
Yeah, actually, Joe. We have an even older PR for that 771 issue
Yeah,
by Rock.Geo that it might be look better, but I'm not sure. Like, yeah, it's an old PR, so I'm not sure how it works now
Yeah,
with the
that
current
one, like,
state of SimPEG, but
I don't think that one's correct either, because it like forms a dense matrix and then does the inverse, like a matrix factor,
Yeah,
which is not
yeah.
good.
oh yeah, ooh.
I think, yeah, we haven't used Gauss-Newton almost at all, I think.
Yeah, so I'm not sure where we're gonna we should probably revisit that and see where it is actually happening like that and get it more in line with the inexact Gauss, whatever solver that we mostly use.
Maybe actually, it's probably worthwhile to deprecate that Gauss-Newton, I think, because yeah, I'm not sure why. You can basically use the inexact Gauss-Newton always.
Mhm.
Sure, you make sure you increase the number of CG to make sure you solve well, and then what you get should be almost equivalent to the Gauss-Newton.
Okay. Well, I mean, we should definitely do something with that. I'm not sure what we can do right now. Either way, like both those things, I don't think are good solutions to it. Looking at them. The next one, extend base source for pole and DC or minor extensions. Soggy, would you mind looking through this one, number 1007? My, I
1007.
think he's made it like it was the thing where you're kind of implementing a multi-pole receiver for DC.
Yeah, I could do that. Huh, it's been a while. Okay.
Yeah.
Yeah, I'll do that.
My thoughts are that it'd probably be better to have it be a separate class rather than having pole and dipole both depend on it. But if it works fine and you're happy with it, I'd be fine to accept it. Depth weighting function and model utils. I've already talked to Dom about that one. Simulation MT part 1. Where are you at with that, John?
I just got to write some more tests. Just the code coverage is just failing still. So I started to go through it a little bit. I see what I need to do. So yeah, I'll work on it for sure.
Okay, cool. No, no worries, just going through everything.
I just want to play with my cluster last week.
Cross gradient joint inversion. I know I've been going through it a bunch, so I still got some stuff to put on there. Should get that in. I'm working on that one. Okay, add license and copyright to every PI file. This needs to be updated for the new files that are in, I think. I'm still in favor of adding the copyright to every file, but we need to get this back updated.
But you could just put the one-liner. He has put that here.
Yeah.
I think it's a necessity.
Yeah.
Just if someone copies it out, a file from your code. What is it's the MIT, right? SimPEG.
Yeah, it's MIT.
Well, it wouldn't be too long, but yeah. What I don't like too much is having the year in all of them. I have it in mine too, and then you have to update it all the time, and it's sort of painful. But the license itself, I think.
So right now, it was just as like copyright 2013. Everything, right? Like every file had that same.
Which is, I think it's not legally watertight, but the hyphen isn't either. You should have all the years where changes were done, and it's stupid. Yeah.
Jeez, really?
So I think 2000. There are no precedent in court, but what of stuff what I read about licensing, 2013, 2020, and if you put that on a file that would have been created in 2015, you're already in the gray zone because you're writing in 2013 when this file didn't exist yet. So yeah.
Mhm. Oh man, life.
I think that the license type is the important thing. Maybe even the license type and the link to SimPEG.xyz would make more sense. Just that if someone copies it, you would see it from the file, what license is it under and where could you find more information? Where does it come from originally?
Okay. So next, we've got the EMG 3D integration. That's still just a draft PR. You guys are still working on that one, right?
Yeah.
Yeah. Well, we actually need to revisit soon because
So it's in a frozen state
Yeah.
at the moment. It will come along eventually.
It'll come along. I think we just need to deal with this memory leakage stuff. But other than that, most of things are working.
It can be used, yes.
Yeah, we just need to fix that and add the magnetic receiver. Well, we do have a receiver, but we just need to make sure that passes the odor test and
Make it better. Yeah.
but then yeah, it'll come together. we'll show some big CSCMTN version at some point.
So then the next one, there's the representation for survey sources and receivers. I know we kind of let that one get off. Like just kind of.
Problem there is it's only for 2 cases. Ideally, it would be for any source and receiver, but then it's a much bigger task, right?
I don't. I think I might have pushed a change or 2 in there.
You put some changes, yeah.
Yeah, I think I was decently happy with it. I just update it and make sure it passes. Okay. So there we have this examples MT1B from about 2 years ago now. We're almost to the end of them. What do we have 1 TMD examples in there right now? Like, is this no longer needed? Because right now it's just it was like literally a tutorial or example. So I'm assuming, Devin, that we had added a tutorial for the 1 TMD MT at some point.
It also, it still says work in progress, so I guess it was never fully finished.
Yeah.
Yeah, I think it's just probably worthwhile to replace like not all of them, but just put simple, like I want the example using the analytic function. I guess that's probably.
Yeah. I was just curious. I wasn't sure if we had that in there yet. Doesn't seem like we have any of the like a tutorial for 1D EM yet. So I'm just gonna leave it there for now. If you want to use it to build off of it, go ahead.
I don't know if actually the last one can be close or not, or it's probably heavily outdated.
Yeah.
I think Lindsay started a Google Docs at some point, and then it also got outdated. Yeah, she started a Google Docs. So yeah.
Okay. Yeah, I was just not sure what to do with that one yet since it was such a while ago.
I don't think it has been changed. So the
Uh-huh.
original issue sort of still stays, but yeah, it's not, yeah.
Well,
maybe when the, what we talked about, when SimPEG does the inversion seminars, then there will come a good summary of what is an inversion that we can slap to the SimPEG docs.
Yeah.
What do you
Well,
think, Sogi?
I think it's all come, maybe all come together at some point. I think it is also working hard on writing inversion module as like it's a text. But I think that's more kind of providing a theoretical point of view of how SimPEG works, how inversion works. So maybe that can be related to this at some point. Could change something, but yeah, I think we could just let it open, although that's outdated, but it's probably worthwhile to have.
okay.
I realized that you closed that EM1D stuff. Do you think it was like good enough to be merged, or what was sort of your intentions? I was kind of revisiting and wanted to make sure, like, I wanted to actually merge that kind of as soon as possible.
Which one?
It was number, where's that? Let me see.
It is merged, 1013.
Oh, is it merged?
Oh, I might have, I didn't.
Yes, it is
no.
under the merged ones.
Oh, you merged it.
963.
Oh.
You closed 18 hours ago.
963.
Which one? 913?
963.
Oh, yeah.
Nine, 6, 8,
3.
963.
It's a huge one of merging SimPEG EM1D into SimPEG.
Yes, it's a big.
I might not have mean to. That might have been an accident. I don't know. How,
Sounds good. Then can you reopen and
yeah.
yeah, it's kind of timely. So I'm working on writing a book about EM induction for groundwater, and I want to actually use this tools and as a separate resources for the book. So I want to make sure all the functions of that we have is working. I think it's actually working. All of them are working. It's passing the test. I just need to make sure, so, like, update the tutorials that have been generated.
Yeah. I saw you had updated a. Sorry, I didn't mean to close that one. I don't know how that happened.
Where's
Might just been a misclick. Thank you for bringing that up.
Mm.
You had to add a sign, like a sign difference there.
Oh, that was my mistake. That was my bad. There's no,
Okay.
there were no problem.
Okay.
So I had to, like, I was playing with like the signs and
Gotcha.
um,
Yeah, just make sure we get all the tests back in there.
yeah, I think except the height, I think it's all of the tests are passing. I think
Yeah, I would love to get a height derivative test in there.
right. The difficulty is now the current version has actually, you find all the unique pairs of sources at the same height. Then I need some sort of index like that said, oh, it's a single height. Like, so
Yeah.
I had before, but now it's somewhat ambiguous. So I think all the functionality, I think it's working, but they just kind of bit of a logistic problem. How are we going to set? It's a problem, inverse problem, because we can set like number of heights for each of the source, but that's not meaningful. So we need to think about a good way to index. Okay, we're still inverting for single height. that I wasn't 100% clear what's the good way to go.
Oh, it should be pretty simple. Just using the like just map between the topography, like a topography XYZ to the source location. That should be all it needs.
Right.
That's it. Like just a,
Still, we need something like similar to what that did. So we need some sort of reference height, and then everything is relative. So you're just inverting for reference height, and then other
right. Right.
other things.
My point is that all you needed was all we need is a matrix like like an interpolation thing that goes from the quantity defined in space to the location of each source.
Yeah.
That should be it.
Yeah. So I was hoping we could deal with that a little bit later, because although it's actually probably simple, but needs some thoughts, I think, and it probably need extra parameter in survey class, I'm not sure. So if you if you have a great idea, we could just implement quickly and merge, but I thought it's not necessarily important.
It'll just, my thought would be, okay, just use like a however you have your mesh defined. Like you could have like a 2D mesh if you have the sources in on a plane, right? You could just have a 2D mesh and then just use an interpolate to source location. That's all you have to do.
Okay. So anyway, so that's where am I for
Okay.
that.
And then we'll just need to go through and just parse out the things we talked about getting into SimPEG quickly, right?
I think it seems like you've already done the parsing things out. That's
Yeah, we just need to remove some of the other stuff for now, so it's not just floating around in the code base.
Oh, right. Yeah, we could remove some of the old part.
Yeah. Okay. I think that's all of them. Thanks, guys, for sticking around.
Thanks, everyone. Have a good one.
See you next week.
Thanks, guys. Sagi, do you have a moment to